Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be understanding friction concept. Here, this is a topic from engineering mechanics and it is useful for BTech mechanical as well as civil engineering and even GATE examinations also. So, in today's class, you will be learning the complete concept of friction. And let us look at that various contents. What you are going to understand from this lecture is friction, the basic concept, limiting friction, and the detailed classification of friction, and lastly, the laws of friction, the important laws of friction you are going to understand from today's lecture. So let us look at this. The very first topic of this is basic concept. Basic concept of friction. To understand the basic concept of friction, let us consider a block. A block is resting on a plane surface having a weight of W, and it is resting on a plane surface, and it is connected by means of a flexible member and passing over a pulley such that the other end is connected to the a system of weights you have, right? So this is what is the system you are going to have. Let us look at this, and this is the figure you are considering, and in this you have weights. You are going on increasing the weights, and let us draw the free body diagram of this particular block. The weight is acting vertically downwards, and the normal force N, and it is tending to move because load is acting, external load, let us say P is acting to the right, and the block is tending to move to the right. So here frictional force is acting opposite to the direction of the impending motion of the body. So this is what exactly the diagram we are considering. Here we are very much interested in how exactly this friction is going to exist. Let us consider for that matter a small portion of the block. I have selected this particular portion, and I am going to draw the magnified view of this particular block. Magnified view of the, so the contact surface, I am very much interested in the contact surface between the block and the horizontal plane. So if you see that with your naked eye, and probably if you touch it you feel that it is smooth, but it is not so. If you observe and in a microscope or in not exactly microscope, the magnified view, if you see that, so this is the magnified view of this particular small portion, and obviously you have certain peaks and valleys. The surface irregularities are going to exist, whatever may be the smooth surface. At certain portions, the peaks and valleys of both the horizontal plane and block will be interlocking. The moment you apply the force, what happens? This interlocking between the the horizontal plane and the block takes place, and once it is the force is applied to the right, so it is tending to move to the right. Obviously, because of this interlocking, there is a resistive force is developed in opposite direction to the impending motion, direction of the motion. This is what is x impending motion direction. So this exactly. So now you can define what is meant by friction. So friction is defined as if a block is resting on a horizontal plane, and because of the interlocking between the surface irregularities between the block and the body, a resistive force is developed, and which is exactly acting opposite to the direction of the impending motion, that is x, is called friction or force of friction. We are calling it as friction simply, and you can call it as force of friction. So this is what exactly the basic concept of friction. And if you look at the various applications of the friction concept in certain areas we are going to utilize this friction concept as advantages, and at certain locations it becomes a disadvantage. So let us look at that application part. What you have is here the applications are concerned, friction applications are concerned. If you look at this, you have you know brakes, and dynamometers, brakes and dynamometers, clutches, clutches in which you would like to see that it is you want to increase the frictional force, and probably in certain applications where the force of friction is utilized, or even you know um, brakes and dynamometers and clutches, you have even in screws also the friction is moderate friction is required in screws. We call it as screws. And in certain applications the friction becomes a disadvantage. There you want to minimize the frictional forces. The mainly in bearings you want to reduce the frictional force while transmitting the power, because of the friction there is a loss of power. You want to minimize the loss of power. And shafts, bearings as well as gears, of course screws, where we want to have here you want to have moderate friction and you want to minimize the friction. So these are the various applications of friction in mechanical engineering. Now let us understand the limiting friction concept. So to understand this limiting friction concept, let us consider the same diagram which I have given here, limiting friction, this particular diagram. And you see that when the force is P is gradually are going on increasing by means of a system of weights which is given. So initially let us assume that you have, I am giving a simple table in which you can understand that you have a table. One is, let us say the serial number 1, 2, 3, 4. We are giving considering only 4 weights. Let us say the externally applied force P and frictional force. Let us assume that external force is 0. There is no force acting. That means you did not load anything. So when this is 0, obviously the resistive force developed between the block and the contact surface is also 0. So now you can draw a plot between these two. Let us consider x-axis is external applied load, and your y-axis is the frictional force, and this is the origin. You have 0. First point is 0. When external force is 0, the frictional force is also 0. That means when there is no external force acting on the body, there is no friction at all. So assume that you have loaded with 100 newtons force, external force. So here the frictional force is also 100 newtons. So let us assume that it is P is 100 and this is also 100. You have, this is your first point. This is at 100 and this is also 100. And assume that you are increased to 200 newtons because there is no relative motion. The moment you apply 100 Newton force, what happens? The resistive force opposite to the motion also, it is going to develop a frictional force of 100 newtons, but there is no relative motion because the system is in equilibrium. That means the force magnitude is not sufficient to induce the motion in the body, in the system. So that is the reason it is in equilibrium position only. So let us assume that this is also 200 newtons. And another point, you have this is 200 and this is also 200. And the third point, let us assume that it is 300 newton, and at which assume that you are treating that at which the body is about to move. That means the frictional force, as the load increases, the frictional force is also gradually increasing, and let us assume that this is your third point, 300 newtons, and if you join all this, it becomes a straight line, and because both are equal, the angle you can see that it is 45 degrees, and here this particular point is called limiting friction. The maximum frictional force experienced between the block and the system, that is the horizontal plane, is called limiting friction. After this, let us assume that if you load further more than 300 newtons, the body will be in motion. So that means this particular limiting friction, and this is called impending motion, about to move. The body is about to move, impending motion, right? Impending motion. We call it as impending motion. And what happens to the system as it is a straight line, and suddenly there is a fall of a frictional force and almost literally remains constant. Observe carefully the plot between the external force and the frictional force. So this point is limiting friction, and prior to that it is static friction. This portion is static friction, and this portion is kinetic friction. Kinetic friction is also known as dynamic friction, but familiarly it is known as kinetic friction. So this is a plot between the external force and frictional force, and the concept of limiting friction. Here, in all solving all the problems, we are going to consider the limiting friction, that is, the system is in equilibrium and the body is about to move, which is also known as impending motion condition. So we are going to consider that is about to move condition, and the system is in equilibrium, and obviously you can make use of so using all the equations of equilibrium, that is sigma fx is equal to 0, sigma fy also 0, and moment sum about any point is also 0. So here this is what exactly the concept of limiting friction, that is the second topic of today's discussion. Types of friction. Let us look at this types of friction. This is third topic. Here the types of friction broadly classified into three important categories. Let me classify. First one is depending upon the availability of the lubrication. So this classification is according to lubrication. According to lubrication, let us assume that there is no lubricant at all between the contact surfaces. There is no lubricant, which is known as solid friction. This is known as solid friction, which is also known as Coulomb's friction, and which is also known as a dry friction also. Here, let us assume that you have coated with a thin film between the contact surface. The frictional forces drastically reduces, and that friction is called boundary friction. It's called boundary friction or non-viscous friction, solid friction and boundary friction. Third one is film friction. Between the two bodies, a thick film, usually you are pumping the fluid, usually in automobiles we are using this particular, and the frictional force is not because of the surface roughness. The frictional force is only purely because of the viscosity of the oil. So it's called film friction. A thin film, a thick film is coated between the two contact surfaces, so the frictional force is only because of the viscosity of the oil. So these are the three classifications according to the availability of the lubrication between the parts. The second one is let me classify according to state of rest. It is depending upon state of rest. I am calling it a state of rest. So this is you can say, if the body is in rest position, the body is at equilibrium position, we call it as, that is what is the limiting friction condition. We use all the equations of equilibrium, it's called static friction. And if the body is in motion, it's a kinetic friction, it's called kinetic friction. So The body is at either at rest position or the body may be moving. If it is at rest position, it's static friction. And in static friction, we are going to consider the limiting friction condition or criteria. So this is about the state of rest of the body. And the last and third classification is, it is according to the type of motion. What type of motion you have? Type of motion. Here, you may have, there are three important types of motions here. First one is, you know, the body is sliding, exactly this block. The body slides over the contact surface. It is sliding to the right or to the left. This is called sliding friction. And the other is rolling friction. The body rolls like a road roller. The body undergoes a plane motion. It's called plane motion, or it is road roller rolling. You have a rolling contact, a point contact. Second one is called rolling friction. Usually, because of this rolling friction, you will be having either a point contact or line contact. If you say that it is a ball, you will be having a point contact. If it is a roller, you will be having a line contact. And usually, all the bearings, usually wherever you are using in fans and other applications, it's called anti-friction bearings. It is no friction because of this point contact or line contact. The third category is pivot. It is usually the shafts, rotating shafts, supported by the ends perpendicular. The support is perpendicular to the axis of the shaft. That is what is called thrust bearing. The friction experienced in thrust bearing between the collar, you can call it as collar or pivot, that you are arresting the motion of linear motion of this particular shaft against to slide over along the axis, and the friction between the shaft and the support is that bearing is called pivot friction. So this is about the detailed classification of friction. And let us look at the last topic of our today's discussion, that is the laws of friction, and we'll be discussing the important laws of friction. And let me discuss the first. This year I am taking this heading as it is, laws of friction. The very first one is, you know, the friction. I'm calling it as a friction f is always, it is opposite to the direction of the motion. It is always opposite, and it is a tangential. Let me write opposite and tangential. The frictional force is along the tangent. That means you see that here it is the opposite direction. The impending motion is to the right, and frictional force is acting in opposite direction of the impending motion or motion, tangential. So this is the first law. Second law, you see that the frictional force, it depends on material of construction of the particular component. So it depends on material. So I am writing it as friction depends on MOC. MOC stands for material of construction. Let us assume that if you have this particular block is made up of wood, you have different frictional force, and if it is made up of mild steel, you have different friction. Maybe aluminum, different friction. Maybe Teflon. Let us assume that it is a Teflon material. Usually, the Teflon is the material which is available to us, which is having lowest coefficient of friction. The coefficient of friction is it is around 0.05, and that is the reason we use Teflon on dosha tawa. A coating is given because without putting the oil, that is what is lubricant, we will be able to take it out. And Teflon is used here because it's a anti-friction material, and the coefficient of friction is very low, that is a 0.05. And see that that means it is depends on the material of construction. So goes on changes the frictional force if you go on changing the material of construction, the material used for your purpose. So frictional force depends on material of construction. And third law is friction is independent. It don't depends. Independent. It is independent of area of contact. Let me write area of contact. That means how much area you have. Let us assume that you have a 1 meter square area of block, and which is having surface irregularities are high, and you have more coefficient of friction. And you may have the surface roughness is very low. Let us assume that you have a smooth surface. Obviously, the area remains same. If you have a smooth surface, the frictional force experienced between these two is probably it's very low. So that means the area is the frictional force don't depends on the area of contact, but it depends on surface roughness of the particular contact surface. Okay, that is about third law. And lastly, the fourth law is frictional force. Again, it is independent of velocity with which it will move. So let us assume that as you can see this plot in kinetic friction, the frictional force literally it remains constant. As it is, the force is applied, maybe the velocity may be increasing because of the increased force, but it don't change. The frictional force, it is independent, don't depends on the velocity of this particular body moving with relative to the supports. And let me conclude today's session. In this particular class, you have understood the basic concept how the friction is going to exist between the bodies by understanding the surface roughness, and the limiting friction concept by means of a plot you have understood that how exactly the frictional forces increases, and finally the limiting friction, what is the limiting friction you have understood, and which is very important in solving the problems using equations of equilibrium, and the detailed classification of friction also you have seen, and lastly the important laws of friction you have understood. So thank you very much for watching this video.